imagine you are standing in front of a multi-million-dollar jet engine, right?
Yeah.
And you're holding a wrench. You've never actually seen this specific engine before in your life.
Sounds incredibly stressful.
Oh, the pressure is totally on. Every minute of downtime is costing your company thousands of dollars.
Mm.
But instead of flipping through some massive 500-page paper manual...
Or trying to balance the tablet on your knee while you work.
Exactly. Instead of all that, a ghostly three-dimensional replica of the exact part you need to fix just appears. It floats directly over the physical engine, highlighting the specific bolt you need to turn, and even showing you exactly how much pressure to apply.
It's wild.
It really is. Today, we are exploring the moment that science fiction basically becomes standard operating procedure. Welcome to the deep dive.
Glad to be here.
So whether you are, prepping for a high-stakes tech strategy meeting or tracking where AI is moving next, or you're just insanely curious about what the future of physical work actually looks like, this is for you. We are examining a massive inflection point happening right now in June 2026. A company called EON AI Ventures has announced that true augmented reality has finally crossed the commercial threshold.
Yeah, and for anyone who has followed enterprise tech over, say, the last decade, augmented reality has been one of those terms that carried a lot of baggage.
Oh, for sure. So much hype.
Right. It was overpromised. It was consistently underdelivered. We spent years stuck in this really awkward phase where, the idea was brilliant, but the execution involved these massive, heavy headsets.
The ones that gave everyone motion sickness.
Exactly. Or the software was little more than a gimmick. But what makes this specific moment in June 2026 so critical is the closing of a massive gap. It's the gap between what software can imagine and what hardware can actually survive in a gritty industrial environment. We're finally moving away from flat screens and entering a reality where digital information shares the exact same physical space as the worker.
And our mission today is to really unpack that transition. We're going to explore how AR has leaped from clunky interfaces to these interactive holograms sitting right in the room with you, and more importantly, how that fundamentally changes human labor.
Because it changes everything about it.
It really does. But to really grasp what EON is doing, we first need to establish why this precise hardware moment is so revolutionary. Basically, it's the leap from working in bits to working in atoms.
Bits to atoms, yes.
Because up until incredibly recently, if you wanted to digitize a frontline worker's job, you had to force them to look at a screen.
And the friction of those screens was the ultimate bottleneck. The enterprise market was essentially fractured into two very limited, often really frustrating categories of smart wearables. First, we had the camera and audio glasses, like the early Ray-Ban Meta devices are a perfect example of this.
Right.
A worker could wear them, and a remote manager could see what they were seeing through the camera. But the glasses couldn't show any information back to the worker. It was just a one-way extraction of data.
Right. So it was basically just a camera strapped to your forehead. You could talk to somebody, but your actual environment wasn't being augmented at all.
Not at all. Then the industry tried to solve that with the second category, which were heads-up display glasses. These introduced a really small, fixed, two-dimensional panel inside one of the lenses.
Like having a little notification ticker tape just sort of hovering in your peripheral vision.
Yeah, exactly. Which is a great way to read text alerts or maybe glance at a temperature gauge, but it's completely useless if you needed to understand the spatial relationship between two complex physical objects. If a technician wanted genuine, spatial, augmented reality before this current generation of hardware, they basically had to resort to holding a ruggedized smartphone or an iPad.
Oh.
They literally had to hold the tablet in one hand, point the camera at a machine, and watch the digital overlay on the glass.
Which is, that's completely counterproductive when you were supposed to be fixing a machine. You only have one hand left to actually hold a wrench or, manipulate a wire.
Yeah.
Okay, let's unpack this because the contrast here is just wild. It's the difference between taping a tiny TV screen to your face that feeds you a text message versus having a fully rendered 3D phantom engine sitting directly on your workbench that you can walk around.
You can walk around it, crouch under it, inspect it from every single angle. And that phantom engine staying locked to the workbench, that is the defining characteristic of true AR glasses. These new devices, they present a full-color, high-resolution image to both eyes simultaneously.
Both eyes. That's the key, right?
Yes. Feeding visual data to both eyes is what tricks the human brain into perceiving genuine depth. You aren't just looking at a flat picture of a box anymore. Your brain actually believes there is a box taking up physical space in front of you.
Wow.
Furthermore, they use on-device spatial mapping, meaning the sensors are constantly scanning the geometry of the room to lock that digital content to the physical world.
Okay, so if I place a virtual pressure valve on an actual physical pipe, it doesn't just float around in my vision when I turn my head to look at my toolbox.
No, it stays glued to that specific spot on the pipe.
That spatial mapping is everything because it leaves both of your hands completely free to do the actual heavy lifting.
Exactly. Moving out of the realm of bits, staring down at our phones and monitors, and stepping into the realm of atoms where the physical work actually happens, well, that requires hardware that can keep up. And as of mid-2026, the device landscape has finally arrived.
We're seeing it everywhere.
We really are. Snap is opening pre-orders for its standalone Specs AR glasses right now. These are binocular, meaning they project to both eyes. They are completely standalone. You don't need a phone in your pocket, and they offer a 51-degree field of view.
Wait, I want to pause on that field of view spec for a second because I feel like those numbers get thrown around a lot.
Yeah.
A 51-degree field of view means you aren't just looking through a tiny keyhole anymore. The digital overlay covers a really substantial portion of your natural vision.
Which is critical if you're working on a large piece of machinery.
Right. You need to see digital warning labels popping up in your periphery.
Absolutely. And Snap isn't alone in this push either. The RayNeo X3 Pro is shipping to developers right now, and they are bringing standalone AR with 6 DOF tracking.
Okay. 6 DOF. 6 degrees of freedom. For anyone who isn't like super deep in the VR and AR hardware weeds, can we break down what that actually allows a worker to do?
Yeah, so 6 degrees of freedom means the headset understands your movement in every possible direction within a 3-dimensional space.
Okay.
Earlier headsets often only had 3 degrees of freedom. They knew if you tilted your head up, down, or side to side, you could look around from a fixed point. But with 6 degrees of freedom, the headset tracks your actual position in the room. You can physically walk forward, lean in close to inspect a microchip, step backward, or duck underneath a pipe.
And the holograms react.
The digital holograms react to your physical position in space perfectly.
That is what makes the holograms feel like real objects.
Yeah.
We also have the Xreal Aura making waves right now. That one boasts a massive 70-degree field of view, and it runs Android XR. Though it is worth noting that it requires a tethered compute puck.
Right. You have a wire running from the glasses down to a small computer on your belt. But tethering is a really fascinating compromise. By moving the battery and the heavy processing chips off the bridge of your nose and down onto your belt, the glasses themselves become incredibly lightweight.
Which means they're comfortable to wear for an entire 8-hour shift.
Precisely. And when you add Apple and Samsung's confirmed AR roadmaps for the 2026 and 2027 window to all of this, it becomes so clear that hardware is no longer the bottleneck here.
The hardware is real, it's comfortable, and it's purchasable. But what makes this EON announcement a true paradigm shift isn't just the glass and the silicon, it's what these devices are actually doing while you wear them. What makes this hardware so powerful is that it operates as a two-way street. It's an actuator and a sensor at the exact same time.
And this dual role is really the core mechanism of the breakthrough. Let's look at the first half of that equation, the actuator.
Okay.
In engineering, an actuator is a component that moves or controls a mechanism. In this context, the AR glasses act as a delivery surface that prompts and compels the right physical action exactly at the point of work.
So guiding the worker.
Right. If a novice technician is staring at a highly complex electrical grid, the glasses act as an actuator by highlighting the exact blue wire they need to splice. It's delivering the expert knowledge visually right when the hazard is in front of them.
So what does this all mean? If I'm thinking about how this changes the daily grind of a worker, it's almost like a GPS navigation system.
Okay, yeah.
But it's a GPS that doesn't just tell you when to turn left or right. It constantly watches how you steer, how you brake, how you accelerate, and it takes all that data from your personal driving habits to instantly redesign the roads and traffic lights for everyone else in the city.
What's fascinating here is that your analogy perfectly isolates the second half of the equation, the sensor.
Right.
Because while the glasses are acting as an actuator delivering the instructions, they are simultaneously using their outward-facing cameras, depth sensors, and inertial measurement units to capture exactly how you are performing the task.
So it's watching your hands, it's tracking your gaze, and measuring your physical movements.
Yes, it captures the reality of the work environment in real time. And the most valuable piece of data it captures is what we call the delta.
The delta. So
Yeah.
the difference between theory and reality.
Exactly. The delta is the gap between how a task should be done according to the pristine, theoretical, standard operating procedure written by some engineer in an office,
Right, the manual.
and how the task is actually being done by a worker standing on a muddy factory floor.
Got it.
Imagine the official manual dictates that a worker must approach a specific industrial valve from the left side. However, the worker consistently approaches it from the right. The standard procedure says they are doing it wrong.
But the glasses, acting as a sensor, can actually see why they are doing it that way. Like maybe there is a newly installed, undocumented exhaust pipe blocking the left side. The worker's physical workaround is captured.
Perfectly said. A single piece of hardware is now closing both halves of the information loop at the exact same moment. It delivers the theoretical knowledge, watches the human execute the task in the messy physical world, and captures the reality to improve the overarching system.
And this simultaneous delivery and capture, that is the exact missing puzzle piece that EON AI Ventures has been building toward. It completes their enterprise software ecosystem. It transforms physical labor into a continuously improving digital asset.
Yeah, that ecosystem is what EON calls their intelligence flywheel. And I want to stress, this isn't just a catchy marketing phrase.
It's an actual product suite.
Right, it's a highly structured, self-feeding loop of software components. Let's spend some time walking through a scenario to understand how these components actually interact with a worker in real time. Imagine a junior technician dispatched to fix a highly volatile pressure system on an offshore oil rig.
Okay, high stakes.
Very. The flywheel begins before that junior tech even steps onto the rig, with a component called Genesis. Genesis is the capsule mechanism. Months prior, a 30-year master technician performed that exact maintenance routine while wearing the AR glasses.
Okay, so Genesis recorded everything they did.
Everything. Their head movements, their hand positioning, the exact sequence of valves they turned. It ingested that master-level physical intuition.
Wow, so now our junior tech arrives at the pressure system. This is where the second component, field IQ, kicks in.
Right, exactly. Field IQ is the delivery mechanism.
It takes the knowledge captured by Genesis and projects it as a 3D hologram directly onto the physical pipes in front of the junior tech. It is literally guiding their hands, showing them exactly how the master tech did it.
And as the junior tech begins turning the wrench, the third component activates. That's assess IQ. This is the validation layer.
So it's watching them work.
Yes. The glasses use computer vision to actively monitor the work. But assess IQ isn't just recording a dumb video feed. It is analyzing the geometry of the wrench. It can calculate if the junior tech torqued the bolt to the required 50 foot-pounds, or if they skipped a crucial safety check. It ensures absolute compliance and competence in real time.
That's incredible. But let's say our junior tech realizes that by adjusting a secondary release valve first, the main bolt actually becomes much easier to turn. They've discovered a slight optimization in the field.
Oh, okay.
That physical adjustment is recognized by the fourth component, compound IQ. Compound IQ is the intelligence aggregator. It takes that new physical workaround, that delta we discussed earlier, and it uses it to rewrite the standard operating procedure for the entire company.
So the system actually learns from the junior tech.
Exactly. The next time someone goes to fix that pipe, the hologram will show them the new optimized sequence.
And tying this massive data loop together are two foundational systems. You have EON Conductor, which basically orchestrates the flow of data between all these different applications.
Like the traffic cop.
Exactly. And then you have EON Verdict, which serves as the quality gate. Verdict ensures that the new optimization discovered by the junior tech is actually safe and compliant before it ever gets pushed out to the rest of the workforce.
It is a stunningly comprehensive loop. Dan Lajerskar, the founder and chairman of EON, framed this perfectly. He noted that in the enterprise software world, everyone has data, everyone has bits, but the irreducible moat, the ultimate competitive advantage, is capturing expertise in the physical world, human hands manipulating atoms.
Atoms, not bits.
Right. But wait, if this physical world data is such a massive enterprise goldmine, why is EON letting companies like Snap, Apple, and Xreal control the hardware? I mean, why wouldn't a company with a vision this large just build their own proprietary glasses and monopolize the entire technology stack?
It's a great question, but that is actually the most critical strategic decision EON has made. They are deliberately device agnostic.
Right.
Their field IQ software sits entirely above the hardware layer. Think of EON software as a powerful operating system, much like Microsoft Windows.
Ah, okay, I see.
Right. Windows doesn't care if you run it on a Dell, an HP, or a Lenovo laptop. By staying agnostic, EON avoids fighting a multi-billion-dollar hardware war against trillion-dollar tech giants.
Which makes total sense.
Yeah.
And it means as the hardware evolves at breakneck speed, enterprise customers aren't trapped. Like if a company buys a fleet of Snap specs this year, and next year Samsung releases a headset that is half the weight with double the battery life, the company can simply upgrade their hardware. The EON software and all that captured work intelligence transfers over seamlessly.
Seamlessly. And, there is also a highly practical industrial necessity for this agnostic approach. We used the example of an offshore oil rig earlier. An oil and gas facility is a highly volatile, hazardous environment.
Right.
You cannot legally or safely wear consumer-grade electronics on a rig because a tiny electrical spark from a battery could ignite a catastrophic explosion.
Oh, wow. Yeah, so you need intrinsically safe certified hardware.
Exactly. Devices that are hermetically sealed and rigorously tested to ensure they cannot create a spark under any circumstances.
But intrinsically safe hardware is incredibly specialized. And it always lags a few years behind the consumer ways because the certification process is so intense.
Precisely. Which is why EON's device-agnostic architecture is so smart. It means that the very second a new intrinsically safe AR headset passes regulatory approval, EON's software can be deployed onto it instantly. They don't have to rewrite their entire stack for a niche industrial device.
I noticed they're already leaning into this adaptability by building on Snap's Lens Studio. They're incorporating what they call agentic development tooling. Wait, agentic development tooling, does that mean artificial intelligence agents are actually helping to build these 3D training programs automatically?
That is exactly the mechanism.
Whoa.
Yeah. Historically, creating a 3D AR training module required a team of software engineers spending weeks coding CAD models and programming spatial interactions.
Super tedious.
Very. But with agentic tooling, an AI agent can just watch the raw video feed of a master technician performing a task, understand the physical geometry of the machine, and automatically generate the step-by-step 3D holographic instructions without any human coding. That's insane. It collapses the time it takes to create a training module from weeks down to minutes.
And because they aren't waiting to build their own hardware, and because AI is drastically reducing the friction of creating these holograms, they can scale immediately. And that scale leads us directly to EON's ultimate end goal, a concept they call Human 2.0.
Human 2.0.
Because historically, augmented reality was treated strictly as a simulation tool. A company might have like 3 expensive tethered headsets locked in a training room. Novice workers would go into that room, put on the heavy headset, and practice a procedure in a sterile environment before ever heading out onto the actual factory floor.
Right. It was a scheduled event, completely divorced from the reality of the daily shift. But with the arrival of lightweight, affordable, true AR glasses, the paradigm shifts entirely. These glasses transition from being a niche training simulation to a ubiquitous operational tool.
They're just part of the uniform.
Exactly. They are worn across the entire frontline workforce during every single shift while executing every single task.
Here's where it gets really interesting. That means every single worker becomes a continuous capture point. They are generating work intelligence at an operational volume that has never been possible before. We are witnessing the creation of an entirely new enterprise asset class, built completely out of human physical motion and problem solving.
And if we connect this to the bigger picture, to understand the gravity of capturing data at this scale, we have to look at the broader macroeconomic crisis facing the industrial world right now.
Yeah, the labor shortage.
Exactly. And remember, EON isn't a startup that just discovered AR yesterday. They have over 25 years of heritage in immersive AI learning, with deployments across more than 80 countries.
Over 136 million downloads.
Right. They have been laying the architectural pipes for this moment for decades. And they understand better than anyone that the industrial sector is facing a catastrophic loss of institutional knowledge.
Because we have an entire generation of senior master technicians, electricians, and mechanics who are rapidly approaching retirement age.
The brain drain.
Exactly. When they punch out for the last time, they take 30 years of hard-won physical world expertise with them.
They take the subtle intuition that just isn't written in any manual. They know exactly how a specific turbine hums when the pressure is optimized. They know the precise angle to strike a stubborn rusted valve to loosen it without stripping the threads.
And once they retire, that knowledge is just gone.
Unless you capture it. EON's Human 2.0 vision is designed to capture that exact intuition at scale. You capture the master technician's movements today, digitize their physical genius into the intelligence flywheel, and tomorrow, a brand new trainee wearing AR glasses can be guided by that exact same mastery. It is the ultimate defense against the brain drain of retiring experts.
And the implications stretch far beyond just training the next generation of humans. This operational volume, physical world data is the missing ingredient for automation. You are perfectly digitizing the complex way a human hand navigates a chaotic physical environment. This data will be used to train the next generation of humanoid robots and physical AI systems.
We are literally using human physical genius to write the foundational code for physical automation.
It is genuinely staggering to think about. So, to bring this all back to you listening, whether you manage a global supply chain, design tech infrastructure, or just want to understand the forces reshaping the modern workforce, this leap from handheld screens to world-locked AR glasses is a tectonic shift. It completes EON's intelligence flywheel, taking us out of the flat world of bits and plunging us back into the physical world of atoms. It fundamentally alters the way we learn complex tasks, the way we execute physical work, and how we preserve human expertise.
And as we watch this transition unfold, where every physical motion and spatial decision is perfectly captured and digitized to train both humans and future robotic systems, it leaves us with a profound question to consider.
Okay, I'm ready. What is it?
If every physical adjustment we make at work is optimized, standardized, and fed into an algorithmic loop to train the next generation of robots, what happens to the inherent value of unique human intuition? What becomes of those unpredictable, unoptimized, happy accidents that so often lead to true innovation?
Wow, that is a brilliant and honestly somewhat haunting question to leave off on. We've reached the bottom of today's deep dive. Thank you so much for joining us, for unpacking the future of augmented reality in the enterprise, and for staying curious. We'll catch you on the next one.